The Light Quantum, Einstein's paper that changed everything. Imagine this. It's March 17, 1905. In a small apartment in Bern, Switzerland, there's this young guy, just 26 years old, hunched over his desk. His name's Albert Einstein, and he's not some famous professor. He's just a patent clerk. Tonight, he's finishing up a paper that's about to turn physics upside down. It's about something seemingly boring. Why light hitting metal creates electricity. They called it the photoelectric effect. But here's the crazy thing. This ordinary-looking paper is going to completely change how we understand reality. What did this unknown government employee figure out that all the brilliant minds of his time missed? And how did this single paper, submitted on this random spring day, end up earning him a Nobel Prize and revolutionizing our entire world? The world before Einstein. So picture the world in 1905. Physics was like this perfect puzzle that everyone thought was nearly solved. For over 200 years, scientists had been using Newton's laws to explain pretty much everything. This guy Maxwell had figured out that electricity and magnetism were connected, and that light was just electromagnetic waves. Most scientists were patting themselves on the back, thinking they'd nearly figured everything out. A famous physicist, Albert A. Michelson, who was the first American to receive the Nobel Prize in Science, even declared, "There's nothing new to discover in physics now. We just need to measure things more precisely." This quote has been wrongly attributed to William Thomson, also known as Lord Kelvin. But underneath all this confidence, weird stuff was happening in labs that just didn't make sense. And this photoelectric effect was driving everyone nuts. The mysterious effect. Here's what was happening. When scientists shined light on certain metals, the metals would shoot out electrons, creating electricity. But the results were super weird. If you made the light brighter, you'd get more electrons flying off, but each electron wouldn't have any extra energy. Even stranger, if the light wasn't a specific color, nothing happened at all, no matter how incredibly bright you made it. It's like imagine you're throwing tennis balls at a fence. According to what everyone believed about light waves, throwing more balls, brighter light, should eventually knock boards loose. But instead, nothing happens unless you use purple tennis balls specifically, high-frequency light. And then even a single purple ball knocks boards loose instantly. The best scientific minds were completely stumped. The outsider. This is where Einstein comes in. Remember, he wasn't some big-shot university professor. He couldn't even get a teaching job. He was working at the patent office, spending his days reviewing electrical gadgets and his nights thinking about the puzzles of physics that fascinated him. While all the established scientists were trying to force this weird photoelectric effect into their existing theories, Einstein took a completely different approach. What if, he wondered, light wasn't just a wave? What if it also acted like particles, little packets of energy? So on March 17, 1905, Einstein submits this paper to Germany's top physics journal. In it, he suggests something nobody was ready for. Light travels as bundles of energy, what we now call photons, and the energy in each bundle depends on the light's color or frequency. His idea perfectly explained that weird metal and light effect. Below a certain frequency, no single photon had enough energy to knock an electron free, no matter how many photons you had. Above that threshold, even a single photon could free an electron instantly. The revolution begins. Einstein's paper wasn't just solving some weird lab puzzle. It was challenging our fundamental understanding of light itself. If light could behave as both a wave and a particle, what did that mean for everything? And get this. This was just the start of Einstein's incredible year. Over the next few months, he published 3 more groundbreaking papers, including the one with the famous equation. But it was this first paper about light hitting metal that eventually got him the Nobel Prize. Most scientists were skeptical, of course. Even Max Planck, who had introduced some similar ideas a few years earlier, wasn't ready to fully buy what Einstein was selling: the long road to recognition. For years, people debated Einstein's revolutionary idea. The proof came gradually. There's this great story about an American physicist named Robert Millikan who set out specifically to prove Einstein wrong. He spent 10 years doing experiments, and in the end, he had to admit Einstein was right all along. How's that for a plot twist? The final validation came in November 1922, when Einstein received the 1921 Nobel Prize in Physics, specifically for explaining the photoelectric effect. Ironically, they carefully avoided mentioning his work on relativity, which was still controversial. The outsider had become the most celebrated scientist of his generation. The quantum world emerges. Einstein's paper did way more than explain a weird lab effect. It helped launch quantum mechanics, this mind-bending theory about how the tiniest particles behave. This new physics revealed a world that seems completely impossible. Particles can exist in multiple places at once. Certainty gives way to probability, and everything we thought we knew about reality just breaks down. The funny thing is, Einstein himself eventually got uncomfortable with where quantum physics was heading. He famously said, "God does not play dice with the universe," because he couldn't accept that the universe was fundamentally random at its core. But the quantum revolution he helped start kept going anyway. Today, about a third of the world's economy is based on quantum physics. Everything from the chip in your phone to lasers to MRI machines. The legacy. You know what's cool? You interact with Einstein's discovery practically every day. Every time you see solar panels, take a picture with a digital camera, walk through automatic doors, or use night vision goggles, you're seeing Einstein's insights in action. But beyond all these practical gadgets is something even more profound. Einstein's work showed us that reality, at its most basic level, is way weirder than we ever imagined. Light isn't just a wave, it's also a particle. Matter isn't just solid stuff, it's also a wave. The universe is stranger and more incredible than common sense would ever suggest. What started in that small apartment on that March day wasn't just a scientific paper. It was the first domino in a chain reaction that transformed how we understand everything. From a modest patent clerk to the foundations of modern technology, Einstein's story shows how a single insight can change the world. Closing. You know what's mind-blowing? The universe isn't just stranger than we imagine. It's stranger than we can imagine. Einstein's work on the photoelectric effect lifted the curtain on that strangeness, showing us a reality more amazing and mysterious than anyone had guessed. I wonder what revolutionary ideas might be taking shape right now, maybe from someone working outside the mainstream. What fundamental truths about our universe are still waiting to be discovered? The adventure Einstein started back in 1905 is still going on, and who knows, maybe you could be part of the next chapter. If you're into Einstein's revolutionary ideas, check out the books and resources in the description and pinned comment. From easy introductions to quantum physics to deeper dives into Einstein's life, there's something for everyone. Drop a comment about which part of Einstein's discoveries you find most fascinating, and subscribe for more stories about moments that changed science forever. The universe has plenty more secrets to share, one quantum leap at a time.